Welcome everyone. Hope you all are enjoying Node Interactive so far. I don't know if we scared too many people off with, this is actually built as a front-end talk, client-side talk, but there's a little bit of C involved, so hopefully it didn't scare too many people away. So my name is Tyler, and I'm really excited about this because I get to introduce everyone in this room to Duktape. And I currently head up the engineering effort at Hustle, and what we do is we develop a platform that enables organizations to build relationships with people via text message. So as an example of this, I set up a short code keyword, Duktape, that you can text to 33888 if you want to continue and start a conversation related to Duktape, JavaScript, Node, anything like that with a member of Hustle after this presentation, if you'd so like. So we don't actually use Duktape to build Hustle, but we do use a lot of JavaScript. We use it everywhere. We use it in our front end for our admin interface. We use it in our back end with Node.js. We even use it on our iOS and Android apps with React Native. So we love JavaScript. And as a general rule, I seem to think that everywhere we look, and I think most people in this room would agree, we want more JavaScript. We love using JavaScript and putting it in places, and every time I see a little place where JavaScript could be, I would be enthusiastic about putting it there. So as a group, we're also lovers of danger, right? We're addicted to learning and trying new things, and that's why discovering Duktape and playing around with it is so much fun. And I'm going to give you a little primer and some tools to get started with it yourself, but nothing too advanced today. Just kind of give you the feel for what kind of things you can do. All right, so what is Duktape? It's a thing that runs JavaScript. It's an embeddable JavaScript interpreter. And the two most useful things you can do with it are call JavaScript code from C or C++, which enables you to do things like scripting. And you can also go the other way. You can have JavaScript code that calls C code for when things need to be fast. So you have some JavaScript and it's not quite optimized. You can call into C or C++ and leverage that speed and type safety of C and C++. So a lot of you might be familiar with the second because this is exactly what Node add-ons do with C++, right? You can manipulate the V8 engine with C++ code. And everyone, I'm sure, in this room is familiar with the first one because the first one is exactly what a browser is, right? It's C++ code that actually enables you to manipulate and change the behavior of a web page by using the scripting language, JavaScript. Okay, so there are a lot of these around. There's V8 from Google, which powers Chrome. There's SpiderMonkey, which powers Firefox. And those I'm very familiar with from having worked at MongoDB in the past. We've gone back and forth between the two a couple of times as a scripting engine for our database. And there's Chakra from Microsoft, which a lot of people are using nowadays, and which is part of Edge. But what makes Duktape unique is that it has this very specific set of goals. They want to be compliant like everyone else, but they also want to be very portable and have an easy-to-use C interface and a very, very tiny footprint. So while performance is important, they don't care about it as much as some of the bigger guys, and you don't need to strap this massive honking behemoth of an engine to your small little program in order to get a little bit of JavaScript. And so while they do care about performance, it is not paramount compared to the size of the footprint and compatibility and portability and those other goals for the project. So everyone out there is probably thinking, okay, Node 4 and 5, does this thing support ES6? And unfortunately, it does, but just a tiny bit. None of the things that anyone in this room would probably care about. But it does support ES5 and 5.1, as well as some browser enhancements like print, which is your console.log, and alert, which is the same thing, but instead of printing a standard out, you print a standard error, that sort of thing. It's got a built-in debugger, supports CommonJS, modules, and it does regex and Unicode cross-platform, which is kind of cool because you can run it on a Mac, you can run it on a Windows box, FreeBSD, what have you, and it will work to the best of its abilities. And it's very easy to use. So as a result of all of this, people are using Duktape in all sorts of ways. They're creating game engines. They're using it for media center plugins. Sorry, not game engine, creating game engines. They're using it for the scripting for game engines. They're creating media center plugins. They're using it for reverse engineering toolkits, even as a scripting engine for SQLite. There are OpenGL bindings. And this person, Creationix, has created two of the most interesting things that I've seen. First is Duct Love, which is the libuv bindings for Duktape. And that gives you a more Node.js environment, more Node.js-like environment. And that lets you do things like access the file system, et cetera. And he's also created curl bindings, which allow you to do things like HTTP requests. So if you think about it and think about how to apply those things, this makes it really easy to use JavaScript in a C program and leverage the power of JavaScript to do things that are typically really hard in C, right? Like fetching a bunch of web pages asynchronously or doing string manipulations, right? Things that are just an absolute pain in your C code can be trivial in JavaScript and a pleasure, right? So let's take a look, now that I've described kind of what it is, at how you would use this thing. So the distribution actually comes with 3 files. That's it. You get a ducttape.h, which provides your API. You get ducttape.c, which provides the implementation of that API, and a configuration file that's automatically included for you by ducttape.h. So you don't need to worry about it, you just need to have it. And the API looks like this. So it has a namespace like all good C code does, where everything starts, all the functions start with duck. And then you have the function name, and it takes a context, a duck context, and maybe some extra arguments. And if you're cringing and you're a C programmer in the crowd, right, you can also do error checking, right? So all of these functions return a non-zero value if there's something bad happened. And then you can safely print out a string to tell you what that was. There are also P versions of functions. You'll see that there's like eval and p-eval, and the P ones try to parse the code first to see if it works rather than just running it, which can crash your program if it's badly formed. But basically what this API lets you do is manipulate the Duktape internals. And so in order to execute JavaScript, what you need is a heap, which stores variable dynamic data like strings, which can be of any length, arrays, which can have any number of items, or objects, which can have any number of keys and values inside of them, and so can grow dynamically. So it needs the heap, and it also needs a context, which in Duktape parlance is a thread of execution. So there are 2 things associated with this. One is the call stack, which keeps track of where you are in the code execution, what functions you've called, and so on. And when you return, what function to go back to, as well as a value stack, which stores the values of an active call stack. So it's a stack-based API, and the way you use it is you say, all right, I want to duck push number, duck push string, duck push true, and then it manipulates the stack so that it looks like it has this number, this string, and this Boolean. So the way you use it is pretty straightforward. You include ducttape.h, you define a main like every C program that has ever been written, and you create a duck context, a pointer to a duck context. Then you use that context to evaluate some JavaScript, and you throw it away. In order to do something a little more complicated, you're going to need to look at the docs, though. And thankfully, the docs are excellent. They've got a function prototype that shows, OK, so if I'm calling this, it takes context and also a string to the path. They show what the result of the stack is, or what the stack looks like before you call a function and then after you call that function. They have a nice little summary of what it does and most of the time an example. So let's take this knowledge about how it works and leverage calling JavaScript from C or C++. So I made up this file that has some great JS. It's called cool.js. And in it, there's one single function that has that takes a string, and it prints out that it's working some magic. and creates a cooler string by taking the string we passed in and appending is cool to the end of it. Great. We take that string that we created and return it at the end. So in order to be able to leverage this code, what we need to do is evaluate this file, push some arguments onto the stack, and then call the function with those arguments. And so thankfully, Duktape has 3 functions that do exactly that. There's duck_eval_file, which basically takes context and a path and pushes it on the result onto the stack. There's duck_push_string, which takes a string and pushes it onto the stack. And duck_call, which takes a function and arguments and then evaluates them and places the return value on top of the stack, having popped off the function and arguments used to call it. So this is what's going on inside the interpreter, right? You evaluate the file, and at the end of the file, you may have noticed that I had cool semicolon, right? And there's a lot of ways you can do this, but I eventually wanted the result of the execution of that JavaScript to result in the function being placed on the stack. So that's why I have cool semicolon at the bottom there. So I evaluate the file, and it places the function on the stack. I push the string Duktape because I want to ultimately say Duktape is cool. I run call, which calls that function and passes the string Duktape in as an argument, and then it pushes the result back onto the stack. Duktape is cool. You're then able to call duck_toString, which will give you a null terminated C string. Cool. So I've got this JavaScript, and the way I would execute it is by running this function. You say, or this C code, duck_eval_file, duck_push_string, duck_call, and then duck_safe_to_string. There are non-safe variants and variants with the P of all these functions. And I'm doing absolutely no error checking or handling at all in this code, but I wanted to fit it onto a slide. And at the end of this, when you execute the C code, it'll say, we're working our magic, and Duktape is cool. So we've got a little bit of time left. I didn't know how much time we would have, but I can also talk about going the other way, which is leveraging C and C++ code from JavaScript. So this is a more complicated example, but this is a function that adds a variable amount of numbers. And the way you would do this, leverage this C code from JavaScript, is it has to have this certain signature. You have an integer, you have the function, and it takes a duck context. And then at the end of it, you push the return value and say that I have a single return value. This return integer is very important because it dictates actually what the function is returning. You say 1 if there's a single return value. You say 0 if there's nothing or undefined, as you all know. And you can return a negative number to indicate that there's an error and which causes an error to be thrown. So you can create a function that has a counter for a loop, gets the number of arguments that were passed in dynamically, has double, and then counts up all the numbers. And at the end of it, you get a function that looks like this, which can dynamically take any number of doubles, right, or numbers in JavaScript, and add them up. So same sort of thing. In order to call it from a global context, you push the global variable onto the stack. We push the C function that we just created. We put prop, which means I'm going to add this function that I have on the stack into the global variable, and then I pop it off. And then you're able to call it. So the way you do that is by saying all the code that I just showed you before executing on top of the variable stack. And then at the end you can say, duck_eval_string, print 2 + 3 is adder 2 + 3, because we registered this function in the global object, and now it's available. That's all I've got for today. We've got about 5 minutes left. I'm sure that everyone has you might have a million questions about all that because we breezed through it. And there was a lot, and I don't know how comfortable everyone is with C and all this stuff. So do you guys have any questions? Yes?
Can you still use like other packages or libraries or things with this kind of system?
You can. It does support. Let me keep this up for a sec. You can. It does support CommonJS modules. And you have to be a little bit careful because the support is not, it doesn't have all the things that you might expect in a Node environment unless you included Duct love, right, which provides the libuv bindings. You want to have HTTP and things like that, or things that you might normally expect from a browser. So you have to be careful, but yes, ideally, you can, but in practice, you might not be able to. And what else? The module support, yeah, just supports CommonJS, but you also have to register your own function when you do this to kind of figure out how to evaluate the module. And so it's a little more complicated than it actually seems up front. It's a little more complicated than just saying, yes, we support modules or not.
Cool.
Yes?
Is there a roadmap for ES6 support, or is it just not planning on going there?
Good question. I'm actually supposed to repeat the questions, so I'll repeat yours. The gentleman asked if there was a roadmap for ES6 support. I actually don't know if they're going to do that or not. Because you can transpile ES6 to ES5, you can kind of get around it, but eventually it would be really nice to have it. And but they are also concerned on being very standards compliant. So you'd have to ask a member of their team, but I would say that if they're going to do it, they're going to do it fully instead of kind of piecemeal. Yes. Gentleman over there asked how it does with garbage collection. It does really well. So to give you an example, it automatically exposes in the JavaScript interpreter the ability to call the garbage collector, and performance-wise, it's pretty good. You can tell it to run in a low memory mode where it collects more often, or you can let it grow a little bit larger. But in general, the performance is not going to be like that of V8, but it's fairly sophisticated and will do fairly well most of the time. But it's meant to be run in these lower memory environments where you are constrained with RAM and you are constrained with processing power. So just something to tinker with and play around with and have fun with if you're at all interested in how JavaScript interpreters work and how the sausage gets made. Any other questions? All right, cool, thank you.